Good morning, dear students. So, in the previous class, okay, so we were discussing about the reactions, okay, that is the test. Okay, so we have discussed about the reactions which are involving CO bond, right? The cleavage at CO bond, right? So in that we have seen the different reactions. So firstly, we had seen the reaction with hydrogen halide. Okay, so how alcohols react with hydrogen halide. Then we had seen the Lucas test. Okay, to distinguish between the primary, secondary, and tertiary alcohol. As I said, it is very important. Right. Then we had seen the reaction with phosphorus trihalides. Then we have seen dehydration reaction. So very, very important mechanism. So the mechanism is very important of dehydration of alcohols, that is from ethanol to ethene. Okay. So the steps which are involved in the mechanism of dehydration of alcohols is very, very important. So this is a important question asked during the exams. Right. Then also we had discussed about the oxidation and dehydrogenation reaction. So how the alcohols react in the presence of your strong, this what, strong oxidizing agent, how they give you the various products. So these, so with respect to primary, secondary, and tertiary, we had discussed, right? Then we had started with the next thing was that reaction of phenols, right? So today we are going to start with the reaction of phenols. So what are the reactions of phenols? Okay, so what are the important reactions? So firstly, as I said you, phenol. Okay, so firstly, as I said you, so phenols, okay, what they involve? They involve, okay, so they involve the electrophilic aromatic substitution. Okay, electrophilic aromatic substitution reaction. So they undergo electrophilic aromatic substitution reaction. Okay. So what is the reason? Okay. So in phenol, as we know, so why they undergo electrophilic substitution reaction? Okay, aromatic substitution reaction. So we have seen the structure of phenol. So this is a phenol structure. Right. So as we have discussed, so the OH group is attached to the benzene ring, and thus what it will do, it will activate the ring. Okay, and thus it activates. So because of the presence of this hydroxy group, what happens? It will activate the ring, and thus what happens? The benzene ring, it will undergo electrophilic substitution reaction. Okay, and further, whatever the incoming this is there. Okay, the incoming group is there, so that will be directed to ortho or para position. Okay, so the incoming electrophile, what will happen? So it will attack the ortho or para position. So you know this is a ortho positions and this is a para position, right? So with respect to the OH group. So because of the presence of OH group, remember that the ring is activated, benzene ring is activated, and thus it will undergo electrophilic aromatic substitution reaction. So the incoming electrophiles, okay, it will attack the ortho, okay, or the para position with respect to the OH group. So which are the different electrophilic substitution reactions? So we are going to study about nitration and halogenation. Now what is nitration? Okay, nitration means what? Which is the electrophile? Yes, the electrophile is NO2 group. Okay, the electrophile is the NO2 group. So this is the electrophile. Okay, so what is our starting reactant? So we are going to take phenol. Okay, we are going to take phenol. Okay, so 2 moles of phenols, and we are going to react it with nitric acid. Okay, nitric acid. Okay, the temperature condition is 293 Kelvin. Okay, so we are going to take what? We are going to take 2 moles of nitric acid. Okay, that is, and we are going to react it with phenol at a temperature of 293 Kelvin. Okay, what it gives you? And so the temperature given is very low here, right? So this is a very low temperature. So the condition is a very low temperature. So what it forms? Yes, what it gives you? It gives you a, so the electrophile generated is nitro group. So it will attack the nitro group, that is ortho position, or it will attack the para position, right? So this point. So what you get? You get orthonitrophenol. What you get? Orthonitrophenol or para-nitrophenol as the product. Okay, plus water. So this is the nitration reaction. So phenol, what it does? Phenol. So phenol reacts with the nitric acid at very low temperature, that is 293 Kelvin, okay, and produces or gives a mixture of orthonitrophenol and paranitrophenol. Okay, so this is the reaction, okay, involving the nitration. So very important nitration reaction. Okay. Nextly, we'll see that. So now this is with respect to dilute HNO3. Okay, you can see this is with respect to dilute HNO3. Now let us see if phenol, if we take the HNO3 in concentrated form. Okay, so let us take phenol. Let us take phenol. So let us react it with concentrated HNO3. Means what? Concentrated means what? Okay, in dilute, we are diluting it with water. Okay, suppose we are taking 10% concentrated acid. To that, we are adding 90 ml of water and we are doing it dilute. Okay, concentrated means what? We are not adding any water molecules. Okay, we are not adding water molecules. The acid is in its concentrated form. So what we are doing? We are taking a phenol. We are taking phenol. We are taking concentrated HNO3. Okay, so concentrated HNO3 and concentrated H2SO4. So this is our nitrating mixture. Okay, this is called as a nitrating mixture. So whenever we are producing the this what nitronium ion. So NO2 is called as a nitronium ion. Okay, so this is the electrophile which is generated during the electrophilic aromatic substitution reaction of nitration. Okay, so to generate the electrophile, we require a nitrating mixture. So that is produced by concentrated HNO3 and concentrated H2SO4. Okay, so here we are doing a what we are doing it in the presence of concentrated acids. Okay, so we have taken phenol, we are reacting with concentrated HNO3 and concentrated H2SO4. So what will happen? So this is called as a nitrating mixture. Please remember this. This is called as what? Nitrating mixture. Okay, remember this for CT point of view. Okay, so this is called as nitrating mixture. So what we will get? We will get a product. Okay, we will get a product which is phenol. Okay, OH, NO2, NO2, and NO2. Can you name this? Yes, can you name this? So this is 2,4,6 trinitrophenol. Okay, 2,4,6 trinitrophenol. This is called as picric acid. This is called as picric acid. So there can be a question for 1 mark. Give the structure of picric acid. So like this, the question is given. Important. Mark this as important for 1 mark. Give the structure of picric acid, or what is picric acid? So what is picric acid? 2,4,6 trinitrophenol. Okay, 2,4,6 trinitrophenol is your picric acid. Okay. So what we have done here? So we have taken the nitrating mixture. So from this nitrating mixture, we have generated the electrophile, that is the nitronium ion. Okay. So nitronium ion will attack the ortho. Okay, both the ortho position and the para position. Okay, and what you will get? You will get a 2,4,6 trinitrophenol. What will get? 2,4,6 trinitrophenol. That is called as picric acid. What it is called as? Picric acid. Got it? Okay. So let us go for the, so this is about nitration. So what we have done in nitration, we have taken firstly the dilute acid, dilute HNO3. So with dilute HNO3, we are getting a mixture of products. Okay. We are getting orthonitrophenol as well as paranitrophenol. The same when we take phenol and we are reacting with concentrated HNO3, that is with the concentrated HNO3 and concentrated H2SO4. Okay, what we obtain? We obtain that is, this is called as a nitrating mixture. Okay, and what we obtain? We obtain the picric acid, that is 2,4,6 trinitrophenol. Okay, what we obtain? 2,4,6 trinitrophenol. So very important. Please make this a point. Give the structure of picric acid, or the question can be, what is picric acid? Okay, so you have to write the structure and you have to tell 2,4,6 trinitrophenol is called as a picric acid. Okay, so this is about your nitration. So let us go for the next electrophilic aromatic substitution, that is halogenation. Okay, what we are doing in halogenation? Yes, our halogen. Okay, our halogen is the what? It is the electrophile. Okay, it is the electrophile. So let us see. So in halogenation, again, what we are going to do? We are going to take a phenol. Okay, let us take phenol. So let us take phenol. Okay, so this is our phenol. We are going to do halogenation. Okay, we are doing bromination. Halogenation, in that we can do chlorination, bromination. So we are doing bromination. Means what? Our halogen is Br2. Okay, so we are going to take Br2 in the presence of carbon disulfide. Okay, so carbon disulfide is a non-polar solvent. Okay, it is a non-polar solvent. So we are going to do this reaction in the presence of non-polar solvent. So you can use CS2. Okay, what all you can use? We can use CS2. We can use chloroform. Okay, we can use carbon tetrachloride. So these are the different non-polar solvents. Okay, so non-polar solvent, any one of the non-polar solvents you can use. Okay, so what we are going to do, we are going to take phenol, we are going to react with Br2. Okay, in the presence of any non-polar solvent. Okay, any non-polar solvent, right? So at a very low temperature, so again the temperature condition is room temperature, that is 273 Kelvin. Okay, so at a very low temperature, so the temperature is very low. Okay, what you will get again? Yes, what you will get? You will get a mixture of, okay, you will get a mixture of orthobromophenol. Okay, you will get a mixture of orthobromophenol and parabromophenol. Okay, orthobromophenol and parabromophenol. Got it? So this is the reaction, orthobromophenol and parabromophenol plus 2 HBr plus 2 HBr. So this is with bromination, okay, at a very low temperature. Okay, now same. So this is the first reaction in halogenation. Okay, so what we have done, we have taken phenol, okay, and then what we have done, we have reacted with Br2 in the presence of any non-polar solvent. That is, we have taken CS2, CHCl3 or carbon tetrachloride. Okay, anyone you can take at a very low condition of 273 Kelvin. And what we get? We get ortho and para substituted bromophenols. Got it? Yes? Okay. So let us go for the second one. The second one, so what we are going to do? We are going to take phenol now again. Okay, we are going to take phenol. Then what we are going to take? We are going to take excess bromine. Okay, we are going to take excess bromine. Okay, in the presence of water. So this is called as bromine water. So phenol, when it reacts with bromine water, okay, reacts with bromine water. So phenol, when it reacts with bromine water, okay, it will give you a white PPT. It will give you a white PPT of what? What is the name? Can you tell me the name? Yes. So this is white in color. So white PPT is formed when phenol reacts with your bromine. Okay, when phenol reacts with bromine water, okay, then it will give you a white PPT. Can you name it? Yes. Can you name it? So the name of the compound is what? So it is, yes, 2,4,6 tribromo, right? Phenol. Okay. So another reaction. So phenol, when you react it with bromine water, okay, you will get, what you will get? You will get a white PPT. What is the name of the compound? The name of the compound is 2,4,6 tribromophenol. Is it clear up to here? Yes. So the first type of reactions, okay, the first reactions which we have seen is electrophilic aromatic substitution reaction. Okay. Is it clear up to here? So we have completed in electrophilic aromatic substitution. So what all we have seen? We have seen nitration. Okay, we have seen nitration and we have seen halogenation. Okay, so these are the very important reactions. So in electrophilic aromatic substitution reaction, okay, what all we have seen? We have seen the that is the nitration reaction. Okay, in nitration we have seen how the phenol reacts with dilute HNO3 and produces ortho and para substituted nitrophenols, and how this phenol reacts with concentrated acid, that is HNO3 and H2SO4, and gives you uh, and produces what? And produces 2,4,6 trinitrophenol, which is called as a picric acid. Okay, so very important reactions. Then next we have seen halogenation. In halogenation, we have seen when it reacts with Br2 in the presence of non-polar solvent, it produces ortho and para substituted bromophenols. And when phenol react with bromine water, it gives you a white PPT, and this compound is called as 2,4,6 tribromophenol. Okay, so very important. Okay, so let us go for the next one. Next one is Kolbe's reaction. Okay, next one is Kolbe's reaction. Okay, so what is this Kolbe's reaction? So we are going to produce phenol. So we are going to take phenol. Okay, so we know that when phenol reacts with sodium hydroxide, what happens? This your hydrogen is replaced by Na plus. Okay, your hydrogen is replaced by Na plus, right? So we get what? What is the name of this? It is called as sodium phenoxide. This is called as what? Sodium phenoxide. So what we are going to do? We are going to take, or it is called as sodium phenate also. Okay, sodium phenate also. You can call sodium phenoxide or sodium phenate. So very important. Mark this important for 2 marks. Okay, all the name reactions are important in organic chemistry. So Kolbe's reaction. So what is Kolbe's reaction? Sodium phenate, what we are going to do, we are going to produce this sodium phenate. That is how we are going to produce this sodium phenate or sodium phenoxide. Okay, by reacting the phenol with NaOH, we will get sodium phenoxide. This sodium phenoxide is heated. Okay, this sodium phenoxide is heated with carbon dioxide. Okay, at 400 Kelvin, okay, at atmospheric pressure, okay, and 6 to 7 atmospheric pressure, and forms sodium salicylate. Okay, it forms sodium salicylate, and this sodium salicylate, okay, so I'll write the intermediate product. They have directly written the final product. So there is an intermediate product which is formed. So you will get what? You will get sodium. So this is your sodium salicylate. Okay, so this is sodium salicylate. Sodium salicylate. Okay, so this sodium salicylate, what we are going to do? We are going to do acidification. Okay, we are going to do acidification, and we are going to get the salicylic acid. Okay, we are going to get salicylic acid. So let me write it here if you are getting confused. So what we have done? We have taken phenol. What is the first step? We are going to take phenol and we are going to react with NaOH. Okay, after reacting with NaOH, what you will get? I'll get sodium phenoxide. What I'll get? I'll get sodium phenoxide, that is O minus Na plus. Okay. Now this, what we are going to do? We are going to heat. Okay, we are going to get sodium phenoxide plus water. Now this sodium phenoxide, what I'm going to do? I'm going to treat it with carbon dioxide. Okay, I'm going to treat it with carbon dioxide in the presence of 6 to 7 atmospheric pressure and 400 Kelvin and 400 Kelvin. What I'm going to get? I'm going to get sodium salicylate. What I'm going to get? Sodium salicylate. Okay, just a second. So this is OH, and here we are going to get COONA. So what we are going to get? Sodium salicylate. Okay. Now this sodium salicylate, what we are going to do? We are going to do acidification. We are going to do acidification, and what we are going to get? We are going to get salicylic acid. Okay. So what happens here? Here H plus ions, and what you will get? NaCl will be released. Okay. NaCl will be released here. So like this is the reaction. Is it clear? Yes. So let me clear this so that you won't get any confused. So follow this reaction. Okay, what I've written here. So here they have given directly. Okay, so they have not mentioned the intermediate steps. So I have written the intermediate step. Okay, is it clear? Yes. So what we have done? We have taken phenol. We have treated with sodium hydroxide. We get sodium phenoxide. Okay, we get sodium phenoxide. this sodium phenoxide, what we are going to do, we are going to treat it with carbon dioxide. Okay, in the presence of carbon dioxide at 6 to 7 atmospheric pressure and 400 Kelvin, we are going to get sodium salicylate. So this is an intermediate product. Okay, we are getting a sodium salt. Okay, that is a sodium salicylate is nothing but it is in salt form. So this further what we are doing, we are going to do acidification. So what we can use, we can use HCl. So after adding HCl, what will happen? These Na plus ions will be replaced by H plus. So your Cl will be left and this is Na. So this will combine, okay, and you will get what? NaCl. So NaCl also will be what? It will be liberated. Okay. So like this is the whole base reaction. So here the carbon dioxide which we are using, okay, so this is acting as a weak electrophile. It is acting as a what? It is acting as a weak electrophile. So this is our whole base reaction. Is it clear? Very important. So write this, write it down. Very important. Okay, if you did not understand, please ask it again. So this is very important from exam point of view. Yes, clear? Yes, is it clear? Okay. So this was about coal-based reaction. So next we will see Rimmer-Timmer reaction. Next is what? Rimmer-Timmer reaction. Another important reaction. Very important. Mark this as important. Yes, Rimmer-Timmer reaction. Now what is this Rimmer-Timmer reaction? So what we are going to take? We are going to take phenol. We are going to take phenol. We are going to treat it with what? So here directly they have treated here. So what is the first intermediate step is that let me take phenol, okay, and let me react it with NaOH. What will form? Yes, what I'll get when it reacts with NaOH first? So directly two-step reactions they have done here. So I'm doing now separately. Okay, let me do it separately. Yes, I've taken phenol. Okay, I've taken phenol. So let me react it with NaOH. Okay, what will I get it? What will I get? Yes, can you tell me what I'll get? What I'll get? Yes, with NaOH, what I'll get? Yes, just now I've told you in the previous coal-based reaction also. First step, what happens here? See here, O is minus, this is H plus. This is plus, this is minus. Okay. Now, if this is replaced, okay, what will get replaced here? Na plus. So it will be O minus Na plus. What is it? It is a sodium phenoxide. It is called as what? Sodium phenoxide. Is it? Yes. Is it? Right. So what they have done in one reaction only, they have taken both the, so I'm doing it separately. Okay, let me do it separately. So what we have done, so we have taken phenol. So phenol, we have reacted with a strong base that is NaOH, we get sodium phenoxide. Okay, we get sodium phenoxide plus water. Sodium phenoxide plus water. Now this sodium phenoxide, okay, suppose this is the sodium phenoxide now which is formed. Now this we are going to treat it with HCl. Sorry, chloroform. Okay, we are going to treat it with what? We are going to treat it with chloroform. Okay, so let me write it here. So let me treat it with chloroform CHCl3. Okay, chloroform is what? CHCl3. So after treating with chloroform, what I'll get? What I will get? So at our ortho position, okay, the electrophile generated will be what? It will be O minus Na plus and it will be CHCl2. It will be CHCl2. Okay, it will be CHCl2. Now this CHCl2. Now here what we are going to do? We are so here what happens? Minus HCl. Okay, so the HCl will be liberated. Now this further, what we are going to do here, the HCl will be liberated. Okay, minus HCl. Okay, now here further we are going to treat it with NaOH, sodium hydroxide. Okay, what I'm going to get? I'm going to get this ONA. Okay, ONA and CH CH OH OH. Okay. So I'm going to get CHOH OH. So what is happening? One of the Cl atom, or sorry, both the Cl atoms are replaced by your OH groups. Okay. Now this further, what I'm going to do? I'm going to treat it with, I'm going to heat it. I'm going to heat it. Okay. I'm going to heat this reaction. I'm going to heat this reaction. What I'm going to get? I'm going to get OH. Okay, after heating, this will be left as water, right? This will be left as water. H2O will be left, right? So here what I'll get? CHO. I'll get CHO. Okay. Now here still ONA is there, right? ONA is there, right? ONA is there. So again, I'll do acidification, and what I'll get back? I'll get the H plus ion, that is OH and CHO. Got it? So what is the name of this? It is salicylaldehyde. Okay, it is salicylaldehyde. So very important reaction. So in Kolbe's reaction, what we are doing in Kolbe's reaction? In Kolbe's reaction, we are synthesizing salicylic acid. Okay, we are synthesizing salicylic acid like this. OH and COOH. Okay, so this is salicylic acid, and in Rimer-Timmer reaction, synthesizing salicylaldehyde. Got it? Okay, so these are the stepwise reactions. So these are the stepwise reactions. So what all we have done here? Yes, what all we have done here? Just see. So let me explain it again once. Let me explain you again once. Okay, see here. Okay, see here. So what we have done here, we have taken phenol. First step, we have taken phenol. Okay, we have reacted with what? Phenol, we have reacted with sodium hydroxide, that is a strong base. What happens? Your H plus ions are replaced by your Na plus ions here. So you get O minus Na plus water. So this is the first step. So we get what? Sodium phenoxide. This sodium phenoxide, what we are doing? We are treating it with chloroform. When you treat it with chloroform, okay, your HCl will be, so what is reacted here? CHCl2 is reacted, okay, CHCl2. So the, okay, so here what happens? So CHCl2 is the at ortho position. Now further we are going to treat it with NaOH. So with NaOH there will be NaCl ions liberated. Okay. Now at what happens? Both the Cl atoms are replaced by OH group. You can see here. Yes, both the, because after treating with NaOH, what happens here? After treating with NaOH, what happens? All the that is NaOH, all the OH groups are, that is all the Cl groups, Cl atoms are, both the Cl atoms are replaced by OH group. Now, when you heat this, okay, so you can see your OH and your OH. So OH and one H, so that is one water molecule will be left after heating. Okay, and what you will get? So let me write it here. So what water molecule will be loosed. Okay. And you will get this what? O minus O minus Na plus and CHO. Okay. Then further acidification. Why we are doing acidification? Because these Na plus ions are again converted, are to be converted into H plus ions. Okay. So we get what? What is the name? It is a salicylaldehyde. Okay, it is salicylaldehyde. Got it? Is it clear? Is it clear? Or it is called as 2-hydroxy. So very important from exam point of view. Okay. So this is asked compulsory asked question. Okay. So next is so some small reactions are there which are important. Okay. Let us see that. So next reaction is, so we have seen first one is the electrophilic aromatic substitution. Okay, electrophilic aromatic substitution. Full base we saw was Rimmer-Timmer reaction. Then fourth we are seeing is reaction of phenol, reaction of phenol with zinc dust. With zinc dust. Okay, let us see this. So reaction of phenol with zinc dust. So phenol is there. Okay, so this is phenol. When we treat it with zinc, okay, what we'll get? We will get a benzene ring. We'll get a benzene and we get ZNO. Okay, ZNO. So what happens here? What happens here? So your O gets combined with this way. Okay, so you get ZNO. Got it? So this is a reaction of phenol with zinc dust. Okay, so 1 mark question, very important. 1 mark question, very important question. Okay, next is oxidation of phenol. Next is oxidation of phenol. So these are small reactions. Okay, oxidation of phenol. Again, we take phenol. We take phenol. Okay, then we do oxidation. We do oxidation in the presence of sodium chromate, Na2Cr2O7, H2SO4. Okay, and we heat this. We get parabenzoquinone. Okay, what we get? Parabenzoquinone. So this is parabenzoquinone. Okay, so this is a parabenzoquinone. Is it clear? Yes. So these are the two important reactions again. Mark this both as important. Okay. So they can write, they can give you how when when phenol reacts with zincs. Okay. So like this, the question can be given. When phenol reacts with zinc, okay, what is the product form? So when phenol reacts with chromic acid, okay. So what is the product form? So like this, the question mark will be given and you have to tell the answer. So like this 1 mark question is asked. Is it clear? So these are the 5 important reactions of phenol. Okay. Very important 5 reaction. Is it clear? Yes. Is it clear? So these are the very important reactions. So there are, we have seen 5 important reactions of phenols. Okay. So in electrophilic substitution reaction, okay, what all we have seen? In electrophilic substitution reaction, we have seen nitration and we have seen halogenation. Okay, halogenation. In nitration, we have seen 2 more reaction, that is with dilute HNO3 and with concentrated HNO3. With halogenation, again, we have treated with Br2 in the presence of non-polar solvent and another was with Br2 in water. Okay, so these also we have seen. So 4 reactions we have seen. Then we have seen pole base reaction. Then we have seen Rimmer-Timmer reaction. Okay, reaction of phenol with zinc and oxidation of phenol. So very, very important reaction. So I hope you have noted down. Yes. So these are very important. So this chapter is only very important because you have seen. right? So many name reactions are there, and each name reaction is important. Okay, Lucas, it may be Lucas reagent, it may be dehydration of alcohol, the mechanism of dehydration of alcohol, Kolbe's reaction, Nimmer-Timmer reaction. Okay, and some of the reactions which we have seen. Okay, so these are very important, which are asked definitely in the exam. Then we have seen acidification reaction. Then we have seen acidity, right? How the acidity of phenols is, that is, phenols are more acidic than alcohol. What is the reason? So these all things are very important from this chapter. Okay. So this completes your alcohols and phenols. Okay. Now next, what we are going to start is ethers. What we are going to start is ethers. So we have completed alcohols. Okay, and we have completed phenols also, right? That is the AROH. So this can be example. Then this example I can take is OH. Okay. So we have completed both alcohols also, and we have completed phenols also. Now next is ethers. Ethers is ROR dash. Okay. Next is ethers, that is ROR dash. Okay. So ethers, what are these ethers? So ethers are organic compound. Okay, ethers are organic compound. So they are given ROR dash. So these are the organic compound which is having a O linkage. Okay, so they have O linkage. Okay, as the functional group. So this is the functional group, and generally they are represented as ROR dash. So this is the way they are generally represented. So this is the linkage which is present, and this is generally they are represented. And R and R dash may be alkyl or aryl group. Alkyl or aryl group. Okay, now you know what is alkyl group, what is the aryl group. Okay, alkyl group is like aliphatic chain, and aryl means benzene rings. Okay, so in ethers, so so what is there in ethers? That is, they are generally represented by ROR dash. So R and R dash can be alkyl or a aryl substitute. Okay. So let us see the next is classification. Okay, let us see the next classification. So what is the classification of these ethers? So let me write it here. So classification of ethers. Okay. So these are classified as two types. First one is simple or symmetrical ethers. Simple or symmetrical ethers. And second one is mixed or asymmetrical ethers. Okay, mixed or asymmetrical ethers. So these are the two types of ethers. Okay. So now, what is a simple ether? What is a simple ether or symmetrical ether? So suppose I give an example of CH3OCH3 or C2H5OC2H5 or C6H5OC6H5. Okay. So these are the simple or symmetrical ethers. Now, what do you mean by this? Okay. So if a alkyl or a aryl group, okay, attached to this carbon, sorry, attached to this oxygen. Okay, so the alkyl or the aryl group attached to the oxygen atoms are same, right? On the either side, you can see on either side of the oxygen, the alkyl groups, or this is the aryl group. So these are same. Okay, so then they are termed as simple or symmetrical. Symmetrical means what? On either side of the oxygen, the atoms are same. Okay, so they are called as what? They are called as the simple ethers. What they are called as simple ethers, or the they are called as the this what simple ether, or they are called as symmetrical ethers. Okay, they are called as symmetrical ethers. Now, what is mixed or asymmetrical ethers? Yes, I'll give you example. CH3O C2H5, okay, or C2H5O C6H5. So what you can see here? Yes, what you can see here? You can see that if the alkyl or the aryl group, if the alkyl or the aryl group attached to the oxygen, okay, atom are different. So one is a methyl group, another is a ethyl group. Alkyl group or the aryl group attached to the oxygen atoms are different. Then they are called as mixed or asymmetrical ethers. What they called as mixed or asymmetrical ether. Is it clear? Yes, is it clear? So is the classification clear? So simple or they are called as symmetrical. Symmetrical means what? On either side of the carbon, okay, on either side of the carbon, the atoms are same. Then they are simple or they are called as symmetrical ethers. If 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 across the oxygen, if the atoms are different, okay, if the atoms are different, then they are called as what? They are called as mixed or asymmetrical ether. Is it clear? Yes. Yes, students, is it clear? So this is the classification. Okay. So that is, they are classified as simple and they are classified as simple or symmetrical ethers. Okay, they are classified as what? Simple simple or symmetrical ethers or mixed and asymmetrical ethers. Okay, so this is the classification. Got it? So next is nomenclature. Next is nomenclature. Before that, let us see the structure of a functional group. Okay, nomenclature. Let us do it in the next class. So nomenclature I'll be doing in next class. So let us see the structure of functional group. Okay, structure of functional group. So let me explain this and then I'll stop. So the structure of functional group. So here, see, here is the structure you can see here. Okay, here you can see the structure, it is given. Okay, so here you can see that the bond angle made between CO and C is how much? It is 111.7 degree. Okay, so this is the bond length which is made between the carbon, oxygen and carbon bond. So this is the structure of your ether. Okay, so lone pair of electrons are present on oxygen. So you can see that in ether, around the sp3 hybridized oxygen. So this is a sp3 hybridized oxygen. Okay, because you have a single bond. So this is sp3 hybridized. So what you can see, 4 pair of electrons are there, right? So there are 2 bond pairs. So these are the bond pairs. These are the bond pairs. So 2 bond pairs and 2 lone pairs are there. So there are how many? There are 4 electron pairs. So around the oxygen atom, okay, around the oxygen atom, what do you have? You have 4 electron pairs. That is 2 bond pairs, 2 lone pairs. And these are arranged how? These are arranged tetrahedrally. Okay, they are arranged in a tetrahedral manner. So due to why they are arranged in a tetrahedral manner? Due to the repulsion between the 2 bulky R groups. So there are 2 bulky R groups and okay, so what will happen? The bond angle is increased. Okay, so because of the presence of the 2 bulky R group, the bond angle increases. Okay, and further the CO bond length is 141 picometer. So the bond length is 141 picometer, and this is similar to that of alcohol. Okay, so in ethers, what all is there? 2 bond pairs are there, 2 lone pairs are there. Okay, and these lone pairs are present on the oxygen and they form a tetrahedral arrangement. Why? Because of the repulsion between these bond pairs and lone pairs. Because you can see the alkyl groups are a heavier groups. Okay, so because of this arrangement, they have arranged in tetrahedral manner. Okay, so here the angle is slightly greater than that of the tetrahedral angle. Okay, and the bond length is 141 picometer. The bond length is same as that of alcohol. So this is the structure of functional group. That is our ether. Is it clear? Okay. So this is the structure of ether. So important. Okay. So tomorrow we are going to see the nomenclature of ethers and then methods of preparation of ethers. Okay. Then we are left with physical properties, chemical properties of ethers. Okay. Is it clear? So whatever has been told in today's class, is it clear, students? Yes. Did you get it? Yes. What about others? Sri Varuni has understood. What about others? Okay. Fine. Okay, then I hope you have understood all things. Okay, so whatever things I've told important till now, please go through all the things. Okay, if you find any difficulty, please come back to me tomorrow. You can ask your doubts. Okay, so we can solve it tomorrow. Okay, so please, so till now, so we have completed alcohols and phenols completely, right? So if you face any difficulty, so whatever important things I've told, whatever I have been telling you, so please go through that. Okay. If you find any difficulty, so we can solve that in tomorrow's class. Okay. Fine. So by this, I shall end the session here. Okay. We'll meet in tomorrow's class. So thank you, dear students. Have a good day.